Andy, Andrei, welcome to Hydra 2021.
Thanks for having me, Alexei.
Yeah, thanks.
Yeah, it's Andy. It's a great honor for all the Hydra crew and all our attendees to have you on board this year. That's amazing. That's it from my side.
Yeah, great having you here, Andy. It's been, for us, it's been a journey to invite you to Hydra. We started a year ago, to be honest. You might remember that. So Andy Pavlo is as Alexei said, is a professor of databaseology at Carnegie Mellon. He's well known among experts for his research on databases and like database technology in general. For the rest of us, I would say he's probably more known for the series of technical talks and lectures he publishes and his team on YouTube, which are great if you haven't seen them and you are interested in databases, either under like whatever under the hood technical details or some specific databases, because the recent talks, they cover wide range of different systems, distributed analytics, online transactional processing, all of that. So like if you have interested in that, definitely check out his like database group YouTube channel. And today, Andy will gonna give us official as it gets, a retrospective on NewSQL term. So do you want to say a few words before the talk?
Yeah, I would just say that like I do remember you invited me last year, and I said, "Oh, let's wait till next year because maybe there'll be a vaccine, the pandemic will be over," and I actually would come to Moscow to give the talk. Here we are. I am vaccinated, but of course everything's still remote. So maybe next year we'll be in person.
Yeah. And this year is actual 10-year anniversary, so that's of a NewSQL term, so that kind of coincided,
Yes.
which is, I think, a great time to give a retrospective.
Yes.
Calling it the official 11-year retrospective is not as catchy.
Okay.
Not as catchy.
Okay. Again, ladies and gentlemen, Mr. Andy Pavlo.
Okay. All right, let's jump into this, guys. So as Andrei said, my research area is in database systems. It's the main thing that I care about. I spend time, all my time learning about databases, understanding how they're implemented, what features and functionalities they support, and what makes one database system different than another. So today I want to talk about a particular class of database systems called NewSQL, and they've been around, as we said, for at least a decade now. So I think it's a good point in time to look back and understand, was this actually a real term? Was there something of substance to what these NewSQL systems were trying to provide, and understand what happened to them? As industry has evolved, is NewSQL still relevant? So the first thing we need to do is obviously define what the term NewSQL means. And the definition that I like to use is that NewSQL is a category of database management systems that are designed to support scalable workloads for operational or transactional applications. So there's sort of three key words here that we want to highlight and make sure that we understand what they mean in order to understand what these database systems were trying to provide. So the first one is obviously relational, and this just means that they're predicated on the relational data model that Ted Codd invented at IBM in the late 1960s and early 1970s. Pretty much every major database system, except for the NoSQL guys, which we'll get to in a second, are based on the relational data model. Postgres, MySQL, Oracle, SQL Server, DB2, all these systems are using the relational model. The next is scalable. And for that term, I define it in two ways. There's vertical scalability, where you migrate the database to a new machine that has more memory, better CPUs, better disks, and the database system can then accommodate and take advantage of that new hardware to get better performance. The other alternative is to do horizontal scalability, where you take a single node database system and then you shard it across multiple physical nodes. And then again, the database system can then accommodate that new environment and scale up and improve its performance. And the last one is operational. And then this just basically means OLTP, online transaction processing. Right? And this is going to be different than analytical processing workloads, things that you would use like Redshift or Snowflake for. Right? These are workloads that are trying to run, specifically for front-end applications. So there's three characteristics about OLTP workloads that we're going to care about through the rest of this talk. The first is obviously we want them to be fast. So we're talking about queries or transactions that can finish in the order of milliseconds. We're not talking about full table scans that are going to take seconds, minutes, or hours to run as you would in a Snowflake style system. The next is that these workloads are going to be highly repetitive. So the application is going to execute the same set of queries over and over again, just for different input parameters. I think of like going to a website, clicking on some buttons, filling out some forms. That's going to evoke some application code that's going to evoke queries over and over again, just again with different inputs. The last is that these queries are going to have a small footprint, meaning they're only going to access a small portion of the overall size, the overall database. So think of like something like Amazon storefront. That database is huge, but when you go use their website and you put things in your cart and make payments to on your account and update your delivery information, all of those are each of those transactions or queries are only touching your data, which again is small. So with that in mind, we want to understand, and for this talk, three key questions. How did the NewSQL trend start? Right? What was the environment? What did the world look like at the time when these systems came along? What happened over time, and are these systems still relevant today? Like, if you're building a new application or you're trying to retrofit an existing one, should you be thinking in terms of, okay, is this system I want to use NewSQL or not? And then what do I think is the future of OLTP database systems? Given that we just spent 10 years building all these NewSQL systems, what do I think the next 10 years are going to look like? So I'll say also too, as I go along, if you have any questions, feel free to send them in the chat and interrupt at any time. All right. So to begin, the first thing we're going to do is understand what did the world look like when the NewSQL movement started. So for this, we're going to go back to the beginning of the century in the early 2000s and understand what the applications look like, what were the database needs look like, and then that led us to have to design a new class of systems called NewSQL. So if you remember in the early 2000s, the major change was the internet, right? So now but the internet made it possible for a small group of people or a small organization to construct and deploy an application that would be used by a lot of people all at once. So it wasn't the old days when major corporations or brick and mortar stores, where they were the only ones that sort of had these large number of users that want to use the database and make changes to it. Now anybody can pretty much put up an application and start having a large number of people. So that meant the database scalability challenges were more widespread and more prevalent, and it wasn't always the major corporations that were having these problems and could just throw tons of money at to try to fix. So the internet was the big game changer in this space. So the first choice you had back then was just to take your existing legacy single node database system and just try to scale vertically. And so these are, back then there wasn't a lot of good open source systems. There really wasn't anything, right? I mean, I started programming on MySQL 3, on PHP 3 in like the late 90s. But that was MySQL 3 was a crappy database system back then. Like if you crashed, my ISM would lose data. It sucked. There wasn't all the choices that we have now. So if you had to scale your database vertically, your best bet was to switch to or use one of these expensive commercial systems like DB2, Oracle, or SQL Server. But of course, the challenge with those guys is that they're only able to really scale horizontally, vertically, meaning you just get to throw more money at the hardware to try to get better performance as the number of users using your application increased. But you're going to get diminishing returns because at some point the hardware is not going to get, if I pay twice as much for the hardware, I'm probably not going to get twice as better performance, right? So there was sort of a ceiling to how much you could scale these things. And of course that costs a lot of money. And if you were an early stage startup, you do want to blow your entire budget paying for Oracle. So a bunch of other people were hitting the same problem at the time, and they ended up building middleware systems to deal with this. So with middleware, the idea is that you're going to take multiple single node database instances, like single node MySQL databases, and then you're going to build a layer above it that's going to take queries from the application and convert them into, reroute them to the right node that has the data that you're looking for. Right? So say the application sends a query to the middleware, and the middleware would look up an internal catalog and say, oh, you want data on this node over here. Let me reroute the request or the query to this guy. He would then get the result back and send it to the application that way. So the The challenge with these is actually, how can you build this to be reliable and scalable, and how sophisticated do you want the middleware to actually be, right? So if all your queries are touching a single node, that's fine. But as soon as you have to touch multiple nodes, someone needs to be able to combine that data together. Neither the middleware has to do it or the application has to do it. But now your programmers at your company or organization, they're spending all their time writing the middleware just to make their database scale, and not working on the application, the thing that actually is going to differentiate the company or the startup from its competitors in the business world. Like, nobody's going to care that your database can scale using this fancy middleware, right? The end user only sees what the application is. So this was a big challenge because you spend a lot of money trying to build this piece. And of course, as I said, it's not going to do everything that the database on the node by itself could do, right? In many cases, you couldn't do joins, you couldn't do transactions across multiple nodes. So it was a big challenge. Now, some very famous companies got very big doing this, right? So most famously would be Google and Facebook. Their first implementations of their databases, and actually Facebook even today, was a middleware layer that they wrote in-house to shard single node MySQL instances. And again, Facebook still runs that today. Google has migrated to other things. eBay was using single node Oracle instances and wrote their own middleware. Again, like it's hard for the business to be spending time to build this database infrastructure when they really should be working on the application. So the next thing that came about with this movement then was the NoSQL systems. And what happened here was people recognized that, well, if we're building an application for users running on the web, this thing needs to be running 24/7, 7 days a week. They can't have downtime. And so the traditional database systems, again, the traditional relational database systems would, in exchange for guaranteeing integrity of the data and transactional correctness, they would rather the system go down rather than lose data or have incorrect data. Andre, can you mute? Sorry. Yep. Okay. So right. So a bunch of companies started building these systems where they gave up the traditional guarantees that a relational database system provide in exchange for higher availability and higher scalability. And so as part of this, they end up throwing away the relational model and throwing away schema protections. And if you throw away that, then you're giving away SQL, and therefore you have these custom APIs, right? There was a lot of things they gave up under this moniker of NoSQL. And whether or not they set out to be the leaders in this space, but the two major tech companies were the ones that sort of brought this idea to the forefront. And there was two very influential papers that came out that describe essentially NoSQL systems without using the term NoSQL. So the first was Google's Big Table paper, and then the second one was Amazon's Dynamo paper. Both of these systems eventually, they were built internally at Amazon and Google, but they eventually now expose it to you, and you can get it through their cloud services. So a bunch of companies read these papers and said, well, Google's making a lot of money. Google's able to scale. We should be doing the same thing. And they end up implementing their own versions of similar technologies that were built at these places. So I just wanted to highlight what sort of the three main categories of NoSQL systems that were competing with the NewSQL systems. Again, just to have a frame of reference to understand, what kind of workloads we were targeting in a NewSQL system. So the first have all the key value stores. So the probably most famous one in this one would be, most widely used one would be Redis. Amazon DynamoDB would be another one well used. React was one, Erlang-based key value store. They have since gone under, although it's still used in some for some applications. Then you have the column family or the wide column systems. Cassandra HBase are probably the two major ones in this space. Hypertable has gone under, but Accumulo is one that came out of the NSA in the United States. And the last, of course, is the document databases with the JSON databases, and MongoDB is clearly the most famous one of all these. And again, the key idea here is that in addition to giving up transactions and joins, they're foregoing the relational data model because they would argue that for the applications that people were building on the web, these had a better approach, or these had a better data model. So the So this is all great, right? You're able to use a database that lets you get up and running very quickly in your application. You're able to store data very quickly and always be available. But of course, now the challenge is all the things that they gave up, like schema protections, transactions, and joins. At the end of the day, applications need those things. And so even if your database system doesn't implement these things, somebody's going to have to. And that's going to just getting pushed down into the application. So as great as these systems were for supporting highly scalable applications, a bunch of the functionality that were not available inside the database itself had to now be written in the application. So you had to have your developers who are trying to build a JavaScript application reason about eventually consistent data or dirty data or being able to join two tables or two collections of data together efficiently. And that's not usually a good idea because again, that's they're spending time working on things to deal with the shortcomings of the database rather than the working on things that make the application successful in the business world or solve some real world problem that they're trying to solve. So I'm not the only one who recognized this issue. Google figured this out too, even though they were one of the first ones that built a NoSQL database system. So there's this famous paper on Spanner, which is their sort of NewSQL system that supports transactions, that came out in 2012. And tucked away around the fourth page is this paragraph here that has this very important line that says, we believe it is better to have the application programmers deal with the performance problems due to the overuse of transactions as bottlenecks arise, rather than always coding around the lack of the transactions. So they're basically saying that rather than have every single developer deal with reason about eventually inconsistent data or inconsistent reads, it's better for them to use transactions, even if they're using them too much, and then have a small group of people, a small group of developers who are dedicated to building the database system and improving its performance, have them worry about how to make those transactions perform efficiently rather than just not having them entirely. And that makes the programmers more effective, more efficient. So it's this environment to the rise of the NewSQL systems. And the main idea here is that we're trying to overcome the shortcomings of the traditional monolithic single node database systems, the middleware approach, and these NoSQL systems to scale up to support large front-end applications that need to process a large number of requests from many concurrent users. So we now need to understand in more detail what this term actually means and what these systems look like. So the first use of the term, I would say also too, before we get into this, any questions so far?
So far, no questions, Andy. You can go ahead.
Okay, thank you. Yeah. All right. So the first use of the term NewSQL came from this white paper written by a British industry analyst named Matt Aslett in April 2011. And in this article, he's talking about how the challenges of how the traditional database companies, Oracle, IBM, Microsoft, how they're going to fare against these sort of newer upstart systems that he called or categorized as being NewSQL. So his definition, he says that the NewSQL systems are going to deliver the scalability and flexibility of the NoSQL database systems while still retaining all the guarantees that SQL queries and ACID for these sort of operational front-end workloads. So this is a pretty good definition, but as I said, this was the first one. The next term came in 2011 in a blog article for the ACM written by Mike Stonemaker, the guy that invented Postgres and a bunch of other very well-known database systems. And so the thing you kind of understand about Mike's writings is that he's usually promoting a company when he writes these kind of things. So in this case here, at this time, he was promoting VoltDB, which is, full disclosure, is a system that was based on the research that I did when I was a grad student working with Mike. So just with that in mind, I still think this is still a valid description of what a NewSQL system is. So he lists what the sort of 5 key features that a NewSQL system needs to have. Obviously, it needs to have SQL as the primary interface, and therefore that infers that it's has to have the relational model. It's going to be supporting ACID transactions. It's going to have high single node performance for the database system. Use some sort of non-locking concurrent scroll scheme, and then have a shared nothing architecture. So the first four are not controversial. It's the last one here that I actually would disagree with. And again, the reason why he's including shared nothing architecture, which I'll explain that is in a few more slides, is because VoltDB is a shared nothing database system. So although the first article that I showed in the last slide, there were systems that were not shared nothing, it's Mike here trying to narrow what the term actually means to almost exclusively mean the VoltDB system. Later in 2012, there was a Wikipedia article written about NewSQL, which means, that's how you know you really made it, is when you're on Wikipedia. And so this is the definition that I like the best, because I think it gets to sort of the key elements of both what Stoneberger was talking about and what the Matt Aslett analyst guy was talking about. So the Wikipedia article definition is that it's a class of modern relational database systems that provide the same scalable performance of a NoSQL system for OLTP or operational workloads, while still maintaining the ACID guarantees of a traditional database system. And again, the reason why I like this is because I like it for two reasons. It first emphasizes the key thing that the NoSQL systems are giving up. Like they're giving up transactions. SQL, whatever, the joins, whatever. I think transactions are really the key thing here. And so by emphasizing that that's what they're giving up and the NewSQL systems will provide, that gets to the clear understanding of the distinction between the two. The other reason why I like this definition is because I'm the one that actually wrote it. So I was preparing to go on the job market at the time in 2013. So I figured, okay, well, if I'm going to be going around giving talks about how my research is on NewSQL systems, people need to know what it is. So I figured, let me go slap it up on Wikipedia, and that makes it look more legit. But I didn't think it was going to last for 10 years. All right, so again, another way to think about these NewSQL systems is along sort of two axes. The first is the scalability, like can we go from a single node system to a distributed multi-node system? And then the other axis is going to be, again, the transactional guarantees. So on the bottom corner here, you would have, again, the traditional single node relational database systems like Postgres, MySQL, Oracle, DB2, SQL Server. And again, at the time, not all these systems supported distributed deployments. That has changed a little bit since then. But primarily, they're going to be down here. The NoSQL guys are going to be up here in the corner. Again, they're going to forgo transactions in exchange for having high scalability and being able to shard the database across multiple nodes. And again, the NewSQL system is trying to have the best of both worlds. They're trying to achieve the same scalability of a NoSQL system, but still maintain those transactional guarantees of a traditional database system. So then in 2016, Matt Aslett, the guy that coined the term NewSQL, and myself got together and we wrote a Sigmod record article, which is, if you're not familiar with Sigmod record, it's somewhere in between, it's more formal than a blog, but less formal, less rigorous than a peer-reviewed regular Sigmod paper. So it's sort of it was sort of the right venue for us to opine about what we thought the industry looked like. And so in this article, we're trying to provide a better distillation of what it would mean for a database system to be NewSQL, and then also discuss some of the distinguishing characteristics about these systems and what made them unique from the NewSQL systems or from the traditional databases, and also go a little deeper in understanding, well, are they actually implementing novel ideas here, or are they just re-engineering the techniques that have been around for years or even decades? And so in this, we defined the NewSQL systems to be part of three categories. And I'm going to go through these each one by one. So the first is going to be systems that provide what we'll call a new database system architecture. And so the idea here is that it's a code base written from scratch. It's not a fork of Postgres, not a fork of MySQL. It's written from scratch specifically for a distributed environment. And as I said, we typically, in the very beginning when we wrote this article, we defined these systems to be primarily shared nothing systems. And by this term, I mean one where each node in the pool or the cluster for the database system has its own memory, has its own local disk, and it can't read the disk from another node. So say I have a two node cluster here. If I need this node here to run a query that needs to touch data over on this node, I have to send the query request over the network to this other node, and it's going to pull back or push over the data that I need. And this could either be sending individual page requests, or it could be sending over a query fragment that gets executed on the other side. So at the time when we defined these things, we said, oh, it has to be shared nothing. And I have to admit that was a mistake. We totally missed the transition to a shared disk architecture, which is more prevalent now in cloud-based database systems. Again, so in a shared disk system, you would have a separation between the compute and storage. So you would have your compute nodes that have local memory and can have disk as a cache, but the primary storage location of the database is going to be on some shared disk architecture. So if you're running on-prem, that could be a SAN or NAS running in your data center. If you're running in the cloud, it could be EBS or S3 or Azure storage. So now if my node here wants to run a query and I need some data, it would send the request down to the shared disk architecture, and then this thing would know how to go find whatever device or whatever node had the data that it was needed, and then send the data back up. And so the reason why I think this is clearly the way the future is going for modern database systems. But at the time, almost all of the new SQL systems were promoting this approach. So we missed the boat, and I think they missed it as well. So the systems in this category would be some of them are listed here. Some of them you may have heard of, some of you may have not heard of. Spanner obviously is a famous one from Google, which we've talked about before. And then VoltDB was the one that I was involved in. So almost all of these were shared nothing except for Spanner. NewDB was sort of a hybrid because they had their own key value store, but then every node could maintain copies of things. So it's not a clear distinction like one versus the other. But for the most part, again, everyone was shared nothing. The next category of systems are middleware. And this is just the same thing that we talked about in the beginning, that there's some shim or some box that sits in between the application and single node database instances. And as queries arrive to the middleware, it's responsible for looking up in its internal catalog to figure out what node or set of nodes has the data that the query needs, splits the query up, runs it on those machines, gets back the results, combines them together, and then sends back a single answer to the application. So there were a bunch of NewSQL companies at the time trying to build a commodity version of middleware that wasn't the bespoke implementation at Google or Facebook or whatever company. They were trying to build something that could reuse and resell to other people. And so therefore they had more time to invest in what the middleware could do. And therefore it was much more sophisticated than what most people could come up on their own. And so what's interesting about this is that most of the middleware systems that were out there at the time were going to support either the MySQL or Postgres protocol. Definitely, back in 2015, 2016, MySQL was more dominant than Postgres. I think the tides are changing now, but most of these systems were going to be using supporting the MySQL protocol. So the application thinks it's talking to a single MySQL instance, but underneath the covers, it would be split across multiple nodes. So some of the major vendors in the space under the NewSQL umbrella are listed as here. And again, all of these except for Citus were supporting the MySQL protocol. What's interesting about Citus is that rather than building a completely separate server to be the middleware, they actually just used Postgres itself to be its own middleware, which I think is a clever idea, and it's actually the right way to do it. Whereas all these other ones were just, again, they wrote their own middleware software by scratch. All right, so the last category would be the database as a service. And the way to think about these is it's sort of a blend of the new database system architecture and the middleware approach, where they were trying to provide a hosted database service that, that instead of giving you direct access to the machine where the database system is running, they would take care of provisioning, they would take care of backups and maintenance, and just provide you with a JDBC connection to access the database. Most of these database services at the time were using MySQL as the backend storage on a single node, and whether or not they would do sharding and split the database across multiple of these instances, it depended on the implementation. So these are just some of the ones that were in the space. all of these actually, yeah, all of these are MySQL except for Translattice. That was actually a fork based on Postgres. They called it Postgres XL, and as far as I know, the website's still there, but the project is essentially dead. All right, so again, these are the three main categories. It's the new architectures, the middleware boxes, and then the databases as a service. Now, if you had read the original NewSQL article from 2011, you will know that they also included in the categorization of NewSQL these MySQL storage engines. So these would be replacements to InnoDB that you could plop in MySQL and still have the MySQL front end, still get their query planner and wire protocol, but the storage itself was no longer InnoDB. It was one of these custom engines. And so we decided to throw this out when we redefined what NewSQL meant in 2016, because all of these companies were failing and just either weren't around by that time or just not going anywhere. And this is because the business of replacing InnoDB is basically impossible for single node deployments or single node instances. Most people don't know this. MemSQL and RethinkDB, both of those companies originally started off as replacements for InnoDB in the MySQL storage engine business. Then MemSQL got rid of all the Oracle code, the MySQL code, threw that all away, and then wrote their own standalone database system. Rethink then pivoted to rewrite or write a new clone of MongoDB and got away from MySQL entirely. So around this time, these were the major vendors in this space, and they all basically have gone under, right? I mean, we'll get to this in a second, but like Schooner got bought by SanDisk and basically didn't go anywhere. Akaban got bought by Foundation. Scalability went under or pivoted. DTD went under. TokuDeck got bought by Percona. And as far as I know, they weren't purchased for their InnoDB replacement. It was purchased for their Mongo engine. So this is a hard business to be in, and I don't see this changing anytime soon. So because of this, we decided just to exclude these MySQL storage engines entirely, because it's sort of not in the spirit with what the new SQL movement was trying to achieve. All right, so before I jump into what went wrong, any questions so far?
Yeah, there are a couple of questions. One is, were there any fundamental challenges which blocked engineers to come up with new Sql system without stopping at NoSQL at the time? So like, why didn't we jump straight to NewSQL instead of stopping halfway, kind of?
I think the question is, why did the NoSQL systems transition to add transactions, or?
I mean, like, what are the challenges which like stopped that transition immediately, basically?
Transition from what? Sorry.
From like basically legacy towards the NewSQL.
Okay,
I mean,
so
if we see it as a transition, like legacy, NoSQL, NewSQL. So like, why did we like even like, what are the challenges which stop like transition to all the way through?
Okay, yeah. So the question is, if NewSQL is so great and all the things that I promised you, why are all these failures? So I will get to that. I think that there's a combination of things. We'll get to that in a bit later in the talk.
The other question is about the future, so I'll probably postpone it to the later, because so far we are still in the past.
Yes.
As far as the talk goes.
Yes. But
I'll keep it in mind. Yeah, that's it so far.
Okay, awesome. Okay, so I kind of already previewed that this is things are going to go bad, because I said here's all the thing of these MySQL storage engine replacements that they all went under or failed. So what happened to everyone else? So this is where we're basically at today. So with some few exceptions, what we'll get to, pretty much all the NewSQL companies that I've talked about so far have either closed shop, been sold off for scraps as an acqui-hire or some basic remnants of the technology to other companies, or have pivoted entirely to other markets. So the first thing I want to say is, when we go through this list, I'm going to exclude SAP HANA and Google Spanner, because these companies are not, their existence is not predicated on the sales of their database system, right? Spanner was written originally for the ads internal services at Google. They eventually now expose it to you through Cloud Spanner, but at the time it wasn't the success of Google didn't hinge on whether they could sell Spanner to other people. Likewise for HANA, they built that internally to replace Oracle and Sybase for people running on SAP's ERP or CRM software. Like SAP makes all their money on that stuff, not the database system. You can buy HANA separately, but that's not why it was originally written. So for that reason, I just want to exclude them entirely as we go through this list. All right, so the first thing, you have all the companies that just went bust and straight up closed. So for this, you have Xeround, Translattice, and GDB. Again, these all the companies just don't exist anymore. And as far as I know, nobody acquired any of their employees or any parts of them. Then you have Scalebase. Scalebase got acquired by Scalarc and merged into them. But of course, then Scalarc's going to go get sold off for scraps later in a second. Foundation DB bought Akaban, which is one of those MySQL storage engines that I mentioned before. Then they added the SQL interface on top of their distributed key value store. But then they got bought by Apple. And they were always closed source at the time. And it's not until, I think, last year or 2 years ago that Apple actually open sourced Foundation DB. And as far as I know, they when it came back out, it didn't have this SQL interface. So they weren't taking any new companies for the period from the time when Apple bought them as they went to open source. And their major customer was Snowflake, right? So it's sort of a mixed success because like it's still around. People can now build new cool things on top of it. But it's the, would you say that's a new SQL system if it's not supporting SQL? I would just say no. Citus was actually a success story. Citus was built on top of the extension API of Postgres. Microsoft bought them. As far as they know, they're still putting out releases of Citus on GitHub, as well as the technology has been rolled into Postgres, I think Hyperscale or Hyperplane. So Citus is still around, but just under Microsoft, which is good. All these other companies, though, they were all basically acquired for pennies on the dollar. And either the technology was entirely dropped or rolled into some other product or rebranded. But it's definitely not, it's not a sole company pushing this one product that they were trying to build. And often cases too, the acquirer was the company that was whoever the acquirer was, they were the only or major customer of the database system itself. So like NeoDB got bought by a French company who just happened to be the biggest customer for them. Right, so all these guys are gone. MemSQL in 2020, last year, they rebranded to now Single Store. I would say this is also going to be a success story too, because they're going to go IPO in the next year, but they're not going IPO because, their success was not because they did transactions really well. They're sort of pushing this HAP story. Their success is primarily based on their ability to do analytics on in-memory databases. I remember in 2013 when I went to go visit the MemSQL people when they were just like 10 people, and I talked with the CEO, and he's like, yeah, we don't, because we always thought them as being competitor to VoltDB. He's like, yeah, we don't care about the transaction market. It's nice to have, but we're really targeting the Vertica analytical market. So yes, it's still sort of NewSQL under the Single Store brand, but people aren't going to go to them. People aren't thinking of them as a pure transactional system, right? It's doing a lot more. So that means the only system that's still sort of around that is following in the same path that they set out with in the beginning is VoltDB. Like their story hasn't much changed. They may be changing the marketing, or what sort of markets they're targeting, or what verticals they're targeting. But the core technology and the core ideas of what it's based on is still the same after all these years. All right, so now this gets into the question I think that the audience member was asking is, well, what happened, right? Why did all these companies fail? And what lessons can we learn? I'll also say too that all right, so you say these three out of all the mix are still around or successful. Is that somehow more or less than the average failure rate of a startup? I think it's about on track. I think 90% of startups fail in the first couple of years. So this is not surprising. I think it's worth still discussing why the ones that did fail, what caused them to fail, and what lessons can we learn from that. So the first issue that all these guys hit up with is that just the cold hard truth that selling a transactional OLTP database system is just hard to do. And this is because there's essentially two markets you can be going after, or two categories of people that would be interested in a database system like this. The first is that you have people that have an existing application. And so these are people that are, they have an existing transactional database system that their legacy application is running, and it's working now. It may be expensive, and it may be slow. It may not do all the things that they want to do, but for now, it's still still going to maintain what they have. And so coming to this world and trying to convince somebody, hey, get rid of your legacy database system and switch over to our new startup that has only been around for a couple of years for transactions, for your transactional workloads, that's a really tough sell, right? Because if your transactional database fails, if the OLTP database fails, then your website is down, your order processing system is down, and you can't make money, and people lose jobs over that, right? If you think of if you're trying to sell an analytical database, if that goes down for a day and you can't run your query reports, yeah, it sucks, but the company's still able to ingest new information and still operate its business. But if you can't run transactions, then that's a big problem. So there's a reason why these legacy database systems that are super old from the 1960s or even the 70s and 80s are still around, and people are paying a lot of money for them. Because it's sort of this notion of it's not broke, we don't have to fix it. And they just try to throw better hardware at it to solve any problems. IBM still makes a lot of money on IMS, even though that database system was written for the Apollo moon mission in the 1960s, or Tandem Nonstop SQL. That company's been bought and sold through DEC and Compaq, and now it's at HP. And HP still makes a lot of money on this, and a lot of people still run on Nonstop because it's good enough and it works. So convincing these people to switch over to your new SQL system, that's a hard sell. Then on the other end of the spectrum, you have people that are building a brand new application from scratch. And the startup costs on the engineering side of ramping up a new SQL system is much higher than a NoSQL system, right? Because I got to set up my schema, I got to make sure I'm using transactions. It's depending on what the architecture looks like for the system. I had to set up multiple nodes. That's a hard thing to do for the average programmer. Whereas in the NoSQL world, especially with something like MongoDB, they nailed the first 5 minutes perfectly, because you turn on Mongo, it's easy to install, and then you get a terminal that's a JavaScript console. You just start throwing data in it, and Mongo takes whatever you want, right? And that's a much more pleasurable experience and less friction to get up and running to build a new application in a NoSQL system than in a new SQL system. So I would say this is a business decision. This is very hard to do. This could have been solved by engineering, and I just don't think anybody did a good job at it. Now, again, this is before the cloud, where things were super easy. But think back, 8 or 9 years ago, you had to install stuff from scratch locally and set things up, and that was much harder. All right. Related to all this is that the next challenge is that existing open source database systems are getting really, really good. So the most popular ones are obviously MySQL and Postgres. These are really, really good database systems. MySQL's transition from 5.7 to version 8, that was a major rewrite, but that set them on a path to do a lot of great things in the future while still maintaining good performance. Postgres has been on fire in the last decade. The Postgres development team has increased the cadence in which they're putting out new releases, putting out new features. These systems are really, really good. So now, if you're starting a new SQL company or a brand new database system project, the bar that you have to overcome in terms of functionality and features to get someone to convince them to not use Postgres and switch over to your new system is getting much higher and higher. Even if that company or that new project doesn't need all the features that Postgres provides right now, they look at that and say, well, I might need these in the future. Of course, I kind of want this. And they look at your new SQL system, and you're running TPCC, maybe TPCE, and that's it. So in the very beginning, most people don't have the demands for number of concurrent users and the amount of data that the new SQL systems were going to provide. And Postgres and MySQL were good enough. All right, and the next obvious issue is that the cloud changes everything. So 10 years ago, with some few exceptions, most of the NewSQL companies started under the premise that started their sort of their business with the idea that they were going to go down the traditional path of selling on-premise software licenses, and they missed this monumental transition to the cloud. I say some exceptions because there were things like Xeround, for example. They were an Israeli, MySQL as a service company. They went under for financial reasons. I think they were actually maybe too early. But most of the companies were assumed that you're going to download their software and run it on-prem. And so as things transitioned to the cloud, a lot of these companies were not ready or not able to go, provide a hosted service to make it easier for people to try out their systems. They just weren't set up for that kind of operation. And they eventually, some of them got there. They were still around. Like Mysql, for example, did this transition, but most of them didn't survive long enough to do this. And it's very expensive. It's a lot of engineering work to make that transition. So in addition to missing how the perception or the sort of conventional wisdom that we want to run our database in the cloud, they also have to now deal with all the cloud vendors who are flush with cash, who have the money and the captured audience to make it really easy for them to deploy people to deploy their databases in the cloud. Right? You're already running all your applications in AWS, and Amazon says, hey, click a few buttons here, and now you have a MySQL hosted Postgres or MySQL database running in RDS. And then if you start hitting scalability issues, it's a few clicks or hit a few sliders, and now you're increasing the amount of provision IOPS or you're increasing the instance size. And again, databases are usually very sticky. People aren't going to migrate those things just on a whim. They're going to see how far they can go with what they have for now. So now you're competing against the cloud vendors who can sell things much cheaper than you can because they control all the data centers. They make it easier for people to integrate these new databases running in the cloud in their existing application services. And then on top of that, they take all the money they're making on the reselling Postgres and MySQL and other software, and they now invest to build new databases from scratch that are more cloud native and can take advantage of all the things that the cloud provides. And again, how does a NewSQL startup compete against any of that, right? So Amazon's got Aurora. They took Postgres, MySQL, carved out the bottom half, and make it work better in their environment. Microsoft has Cosmos DB, and then, as I said, Google took Spanner and then took it out of the internal services and made it available to their end customers. So again, that's a hard sell. Like, why would I want to trust a NewSQL startup with my most important data when these are well-funded public cloud companies that can handle all sorts of challenges for people. So getting people to not use these things and use your startup is difficult. All right, so the last issue is this is a bit of a conjecture on my part, where I can't prove that this is the case, but it feels like this matters. Maybe less so now because of the cloud, because the expectation is you want everything as a managed service, so maybe I care less about having open source. But I felt that the NewSQL Systems sort of missed the boat on this, that this is what people wanted. This is something I think the NoSQL guys did great. They recognized that everything should be open source so that people can try things out, and that's how they got the sort of the developer-oriented approach to people using their database system, and then they grew up to be larger things. That's essentially how Mongo got as big as they were. But whereas the NewSQL guys, with some rare exceptions, I can only think of 3 companies that were open source. Everybody else was proprietary closed source software. And so so these guys are open source, these guys are closed source. So I think this actually prevented and inhibited their adoption, because even if people were never going to modify the source code for these database systems, it's just sort of like in the back of your mind, it's sort of this like safety guarantee, or maybe it's more ideological. You say, okay, I'm using open source software and I can feel good about myself. Again, the cloud changes stuff because now all of the database companies that do have hosted cloud services for the databases, they'll give you the sort of the core kernel engine as open source, but like the backend management in the cloud, all that's proprietary software, which is fine because it's probably not useful for the average public. So that's what I'm saying. Maybe 10 years ago this mattered more. I think it's less of an issue now. Of course, the danger now also, if you build an open source database system Amazon can come along and host it for you and make money instead of you. So there's pros and cons to being open source. All right, so before we finish up with discussing what does the world look like now, where's it going to go, and any questions?
There's a question. Some companies move to multi-tier data architecture, data lake plus projections plus streams, etc. How NewSQL fit into the picture?
So the question is basically, if you have disaggregated storage and you have different tiers of data, data lake being the bottom, and then sort of caching layers or intermediate steps along the way, where does NewSQL fit in? NewSQL originally started off of being at the top. It's where you ingest new data, you run transactions. It's the things that have low latency guarantees. And then you would use an ETL process to move things out, either through Kafka or Glue. You'd move things down to your data lake. So NewSQL is always in the front end.
Okay. Andy, how are we on time? Are we getting, because like
I think we have 10 minutes left.
Yeah. You're going to make it?
Yeah.
Great. Okay.
Okay. Let's finish up.
Let's continue.
All right. So the term NewSQL is dead. So none of either the companies are gone, or the companies that were sort of under the NewSQL moniker or umbrella, they're not calling themselves NewSQL anymore. Instead, the term that people are using is distributed SQL, which actually I think is a better term because it sort of correctly captures what they're trying to provide. A SQL database system that is distributed. So now we have a bunch of vendors that are around that are making the same promises that the NewSQL guys were making back 10 years ago, but they're seeing much better success and much better adoption, right? So Cockroach is raised millions and millions of dollars, Yugabyte, PlanetScale, TiDB. These are companies that are actually viable and seeing much better adoption than any of the NewSQL companies that I've talked about so far. But at their core, the technological concepts that or the ideas or the methods that they're using to provide these systems aren't anything different or widely, I don't say innovative, because that sounds like I'm downplaying what they've done, but it's at their core, the first principles that they're based upon are the same that the NewSQL system guys were predicated upon. Doing concurrency call, doing transactions, consensus protocols, fault tolerance, all that is what the NewSQL guys provided as well. It's just engineered differently and targeting a more modern application stack. So I think this is good, right? This is basically saying, yeah, the NewSQL guys said, yes, you do want to have transactions, you do want to have SQL. And now there's a bunch of companies that have come on after the NewSQL stuff started and are actually delivering on this. And it is actually seeing people using this. The people that want these things, which is, I think, is fantastic. In the case of the NoSQL guys, despite making all the claims that you don't need transactions, you don't need SQL, you don't need joins, the ones that are still around have gone and added these things, which again I think is another testament or another example of that the NewSQL system guys were correct on saying you do want all these database functionalities, and then the NoSQL guys said, yeah, these are good ideas. Let's go add them later, right? So like Mongo has transactions and joins. DynamoDB added transactions. Couchbase has SQL joins and transactions. Cassandra has SQL. They got rid of their Thrift APIs, the default, and now they push towards their own SQL dialect. So this is fantastic, right? This is basically saying NewSQL was correct, at least the idea of that these are the things that you want when you build applications. And then now the NoSQL guys are offering them. Now, there are some scenarios where you don't need all these things, right? Some caching layers you don't want, you don't need transactions. That's all fine. And these guys can provide both modes of operation. But if you're trying to build a full-fledged application, these guys are not providing the things that the NewSQL guys claimed you wanted. The only place that really NewSQL shows up now is for whatever reason is in new Chinese database startups. There's another database startup they're at Toshiba, but GridDB in Japan. But for whatever reason, most of the American companies are not using the term NewSQL. They're all using distributed SQL. And the Chinese database startups are claiming now that they're NewSQL, right? And so in their website, you see a bunch of Chinese characters, and then you see the term NewSQL mixed into it. Or in the case of RadonDB, they claim to have a new category of systems called MyNewSQL, because it's a NewSQL database written on MySQL. So I don't know what to think of this. It kind of feels like there may be, the technology that they're building for these database systems is not is innovative and interesting. It's just, for whatever reason, the marketing seems to be 2 or 3 years behind where I think the state of the art is for today's distributed SQL companies. So just to finish up, what I think is going to happen next. So making predictions is always tough, right? Because this is a public talk. I'll make the slides available online, and then 10 years from now, you can come back and say, was Andy, was he making stuff up? Was he correct? So before I talk about my predictions, I want to talk about some predictions I made previously in 2013 about where I thought the database, the database industry was headed, and that sort of calibrate, how good do you think my predictions are going to be, whether I was right on these. So back in 2013, I said that I thought that the adoption of MySQL would slow relative to other databases. And this is because of a fracturing or a fissure between MySQL and MariaDB. So MariaDB is the fork of MySQL after Oracle bought Sun. And I sort of felt that having 2 separate code bases would be a challenge for people to get to use. So I think I was correct that the MySQL adoption relative to other databases has slowed, but what I missed was that Postgres is the reason why it slowed. I think Postgres is slowly going to overtake MySQL in the space. And then I also predicted that MongoDB would be sort of de facto standard for people building new companies. And I talked about how, they have a lot of money and they can fix all the problems that people knew about in Mongo, which they've done. They bought WireTiger, got a better storage engine, got rid of mmap, added transactions, added a bunch of the things that a traditional database system should apply. It's still the first choice for my students, surprisingly. So when I ask them, what database system would you want to use to build a new website or a hobby project, they all surprisingly say MongoDB still. That really hasn't changed. So I think Mongo has that at least that mind share for the youth. All right, so for OLTP systems, what do I think is going to happen? So I think in the next 10 years, it's going to be very difficult for any new startup to come along and replace some of the existing distributed SQL or even the major commercial database vendors in OLTP space. And unless there's another major breakthrough that in hardware, where there's another major transition, similar to the shift from on-prem to the cloud, unless there's this new category of hardware that the existing database vendors are not going to be prepared for, I just don't see it happening, right? I think as I said, these systems are getting very good. They're getting a lot of people using them, and they're going to get better over time. You may argue, is persistent memory going to be a game changer? Probably not, because we've known about persistent memory since the late 1980s, or we've been thinking about them. Intel's got the devices out now. The major database vendors are already trying to incorporate or build that into their system. So it's hard to see building a database system from scratch just for persistent memory and somehow overtaking the existing vendors. Again, because you have to beat Postgres and MySQL at all their features, which is not easy to do. So the only way I think an OLTP database company, a new startup in this space, could overthrow and outperform the cloud vendors on pricing is if things become more automated. So one of the big challenges that every database system still faces today is that you still need a human, like a DBA or a DevOps person, that can understand what the application is trying to do, understand how it's trying to use the database, and then design, configure, optimize, and tune both the logical and physical components of the database itself. So I don't mean at the storage level, are they doing backups? All that is taken care of in the cloud. Think of things like building index, knob tuning, building materialized views, query tuning. All those things still need a human's touch to get them to perform well. There are some tools like AutoTune or things from Oracle or Microsoft that can try to automate these things, but they don't cover everything. And still, humans are still heavily involved in the management of databases. And of course, humans are very, very expensive. So the software is sort of commoditized. The cloud has made things cheaper, but the humans are still the most expensive piece. So if there was a new system that took a first-class approach to automation, I think that's the way you could overcome the challenges of overthrowing the existing systems. Okay, so to finish up, the main takeaway, of course, is NewSQL is dead. I don't think any company should be calling themselves NewSQL. It's sort of like NoSQL. The term is unclear what it actually means. I think distributed SQL is the right way to go forward in terms of branding. So from an academic standpoint, I think the last 10 years were a success. There was a lot of interest in writing papers on transactions, concurrency control, distributed databases in the research community. And so I think that was a revival from previous decades. So I think that was really important. And of course, also I got a job at Carnegie Mellon predicated on my NewSQL research. So from that point, things are great. Things are a success. But I think from a business standpoint, as I showed, almost all the companies that were under that NewSQL umbrella did not have successful exits, and they just did not see the adoption that maybe they had hoped. The distributed SQL systems are doing much better now, and I think the NewSQL guys were just too soon with not the exact sort of product market fit. Okay, so with that, I'm happy to answer any questions both here and in the after hours. Thank you.
Thank you, Andy. There are some questions coming up. One about like the technical details. Are there alternative for Oracle select for update role lock in NewSQL databases? Or should I ask distributed SQL databases?
So the question is there an alternative for...
yeah, for select for update, Oracle style select for update. I think I know like Cockroach DB did that. I think they even have like a blog post about implementing select for update recently, maybe in the last year or something.
Yeah, so which system supports select for update, I don't know, but I would say the way it's actually implemented is not, in these newer systems, is not different than the original concurrency control papers or the research on concurrency control from the late 1970s, early 1980s. Like at the end of the day, to do select for update, you have to take a logical lock on the data you're trying to modify, and there's no magic to make that go faster or work better. It's either going to be two-phase locking or some kind of optimistic or timestamp ordering protocol. So all of that is still the same. Whether or not a particular system implements it depends on whether the engineers have actually written it.
Okay. Yeah, I think Cockroach has something like that. The other question.
At the end of the day is it's going to take a lock. There's not anything magic to make that go away.
The other question, like there was a premise to the question that relational model is still too low level for developers, and they have to do a lot of work to translate higher level concepts apparently present in application level in the application itself to database terms. Like subtypes and correlated keys, and object relational mapping is actually graph database DSL over SQL. Why did we stop at the SQL level and didn't go to like a higher level abstractions like graph databases or something different?
Yeah, so I think, right, so the basic question is, programmers don't think about writing code in terms of relations. They think about writing code in objects. Relational databases don't store objects. Something like Mongo could, and therefore you need, as the questioner asked or stated, you need something like an ORM to convert your sort of procedural code that's operating on objects into SQL commands that can operate on relations or tuples. So why hasn't the industry evolved to have a better programmer-friendly data model for databases?
Yeah, like basically from SQL level to some different abstraction. Sure.
So people have tried this for years. So before the NoSQL systems, there was a class of systems called object-oriented databases in the late 1980s, early 1990s. And there's a bunch of companies that tried to do exactly as you said, like have a better programming interface to operate on data being stored in a database that wasn't SQL. The bunch of the companies aren't around anymore, right? Like, because at the end of the day, SQL was SQL won out, the relational model won out. And I would say that's the same thing you're seeing from the NoSQL guys. The exception of Mongo and maybe I think DynamoDB, all those NewSQL systems that I talked about, they support some variant of SQL running on top of it. I think that there are some inefficiencies in that, but at the end of the day, I think there's trade-offs to like data integrity versus data integrity, data correctness versus performance, and so there's not going to be sort of one magic language that could replace SQL that could do all those things. The ORMs do a decent job at getting you up and running and avoiding having to write direct SQL. It's not the best solution, but I certainly think in the last 5 years, things have gotten a lot better. They're not great, right? Hibernate can be tricky, but it's not as bad as it used to be. So to answer the question, I don't see a more object-oriented database system replacing any of the SQL systems. Okay. And I definitely don't see a graph database replacing any of these.
What about like just multi-API on top of the existing database? Who has that? I think Yugabyte has DynamoDB style API or something like that.
And I think they dropped it though. I think they dropped Redis. They dropped. The last I heard from them a year ago, they dropped all that and they're just pushing SQL now.
Okay, so they still came back to the SQL.
It's not an easy problem, right? And so, again, for some applications, you're right. You don't want SQL. Like if I'm doing get and set on on some kind of key value store cache thing, I probably don't want to run SQL. I probably want to use a key value store that's better suited for that. I'm fine with that. But I think like for the core data for your application, I think the relational model has shown it to be venerable and can handle most situations.
I guess if you don't need like transaction SQL, you just go to key value space or some kind of NewSQL solution, whatever.
I would say like if there's a natural hierarchy in the application, like a customer has accounts or a customer has orders and orders has order items, I think the relational model is the right way to model those things rather than like denormalizing everything into a giant JSON document.
Okay.
So again, for some things, NoSQL is fine. For most people, though, I would say always start with a relational model.
People have questions unrelated to the talk, kind of tangential, where to get such a cool T-shirt.
So this is a limited edition AutoTune T-shirt. We will actually be making them available. They were designed by the two ex-Soviet street artists in Poland, and we'll make them available on the AutoTune website at autotune.com in the next week or so.
Okay, that's amazing news for everyone who loves others and great T-shirts.
Yes.
Okay, I guess we can move on to the discussion zone for like a more detailed discussion, unless there are more questions in the chat.
Okay, the chat has
there is a
the last chance to ask question here. Yes. What about question by Vladimir?
Yeah, Andy, what's your take on streaming SQL as part of a commonly supported standard for the databases?
What my question is like the streaming SQL standard?
Yes. Is there a standard?
They're trying to have one for like the 20th time. Yeah. So they've been trying to add some kind of aspect of streaming to the SQL standard for years. Actually, Stonebreaker and Sam Zadanek worked on one, like I think it was called Stream SQL 12 years ago, and it didn't go anywhere. I know the Kafka guys are trying to add something, or the Confluent guys are trying to add something as well. And there's some aspects like window functions that made into the SQL standard itself. So I think I'm okay with this. I think that I don't know the details of it, but I think there's certainly some things that are if there are extensions to the SQL language to make it better to run streaming operations, I say go for it. I have no problem with it. Yeah, I think
Okay.
window functions were a good example of something like that being successful.
Thank you, Andy.
Yeah. So thank you very much, Andy. Again, it was cool. It was great. It was, short enough. It was long enough. It was like, yes, it was like very, very, strict, very, very cool. Anyway, again, it's a great honor for all of us to have you on board this year. And I just want to remind to our audience that just under the player, you have a web camera button. Just push it and join Andy and Andre in the discussion zone. And thank you very much, Andy, for the keynote. And thank you very much, Andre, for your support during this talk. See you maybe the next year. Personally, I hope so.
Yes.
Yes.
Okay.
Okay.
All right.
Thank you.
See ya.